Hello everyone. I have uploaded 3 videos on periodic properties. On there I have discussed ionization energy, electron affinity and the periodic tables remembering tricks. How you form periodic table. If you have not watched, then I have pinned the link of that playlist in the description box. You should watch that. Today discuss shielding effect, which is the one of the periodic property. Shielding effect. At first, we should understand what the definition of shielding effect. The effect which decreases the force of attraction between the nucleus and outer electron in an element is called shielding effect. This means in an atom or element, the nucleus is in the center, the electrons are surrounding it, so that the when the nucleus is positive charged and the electrons are negatively charged, so there is attraction between positive and negative charge. But due to these electrons, there is electron-electron repulsion and nucleus electron attraction, so that the attraction of this nucleus and electron is somehow decreased due to the two electron repulsion force. So this decrease in force of attraction between this nucleus and electron is called shielding effect. That means it will shield to attract these two. This is due to the reason is here. This is due to that when nucleus and electron attract each other same time, there is repulsion among the electrons. So there is a decreases in force between the nucleus and electron, that I have told you. So these two electrons repulsion each other. This is valence electron and this is the innermost electron. These two electron repulsion, but this electron and this nucleus and this electron attract each other. So due to this two repulsion, this two attraction is somehow decreases or somehow shield. This electron somehow shield this to attract by this nucleus. This is called shielding effect. This shielding effect is also known as screening effect, because this effect is act as a screen between the nucleus and the outer valence electron. This shielding effect, you can also say screening effect, because this electron act as a screen in between these two. Because imagine if you are sitting in a class and you try to see in a outside nature of your class, but there is a screen in the gate, so that you will not see properly that picture outside the classroom. So like this nucleus try to attract this in more efficiently, but due to presence this electron, this will not show effective attraction. So this electron is screened within these two. The important things we will note here. The shielding effect is directly proportional to number of inner electrons. That means this shielding effect, that means the force or the effect which decreases this two attraction is called shielding effect. This shielding effect depends on the number of innermost electron, these electrons, except the valence electron, because if there is more and more valence electron, then it will repel this outer valence electron, so that this two attraction is minimized, so that more and more of inner electron, there will be more of shielding effect. The shielding effect, so that shielding effect is directly proportional to number of inner electrons. After that, penetration of orbitals to the nucleus or screening power of orbitals are as follows. That means the orbital that penetrate toward the nucleus, or which orbital acts as a screen most efficiently, or which orbital can act as a screen than the others. Their order is this: ns, np, nd, nm. Because s orbital in a same number of cell, n each number of cell, so in a now same number of cell, the orbitals s, p, d, f order is here. Because s is spherical shape, so that in all around it will cover or screens in all around. But in p orbital, because s is spherical, so it will inhibit this is positive charge this electron, so this outermost electron, so this positive charge attraction of this nucleus are shielded from all around because this s subshell is in spherical. But in case of p is a dumbbell shape, so these two sides are act as a screen for nucleus and outermost electron, but these two sides are naked or this side are gapped, so that these two sides a positive charge can attract the outermost electron, so that, and d is also double dumbbell. So that in the 4 side this is naked, so that this can not act so efficiently as a screen, and f is also diffuser, so this order is like this. You have to remember this and this point, and I think you understand the shielding effect properly. Then go to effective nuclear charge. What does it mean? Due to shielding effect, you have read or understand shielding effect. Then due to shielding effect between nucleus and outer electron by inner electrons, there is a less force of attraction between nucleus and outer valence electron. You know that due to the shielding effect, the force of attraction between nucleus and outermost electron somehow decreases. This less charge or attraction is called effective nuclear charge. This is here is the amount of force decreases the attraction between the nucleus or positive charge and the outermost electron is called effective nuclear charge. This can be calculated by this formula. This z star is effective nuclear charge, this z is the atomic number of that element, that how you calculate the effective nuclear charge. Then sigma is the screening constant or shielding constant. After that, how you calculate of z star and sigma by Slater's rule. That means this effective nuclear charge and shielding constant we have to calculate here by using the most usually Slater's rule. So what does Slater rule tell? What Slater's rule will tell? We have to follow these rules. This is Slater's rule. We have to follow these steps to find out the effective nuclear charge and shielding constant. So first, write down the electron configuration of the element. At first, the element we want to calculate effective nuclear charge, we have to write their electronic configuration. After that, we have to divide like this according to their n value, means number of cells. The 4 4 3 3 3 2 D and SP are separately written, so that 1 2 3, but 3D and P different I have told. Then 4 like this. Now selecting the electron for which calculating the sigma. Now for example, if they have given calculate the Z effective of potassium on its 4s1 electron, so that the particular electron they have told. Then what is the contribution of the electron, how we calculate here? All electrons in groups outside the electron is 0. That means suppose they ask for s 1 electron, then 5p6 also given, but we cannot consider 5p6 because they told only for s1, and after that we should not consider it, so that contribution is 0. Then all other in the same group is 0.35. Suppose for s1 told, then for s1 we have to minus 1 electron from the last, because we want to calculate the sigma value on that electron, so that electron will exclude. Suppose there is 4s2 written and told write down the sigma star, sigma or z effective on 4s2 electron. We have to subtract this from this 2 electron. We have to subtract 1, 2 minus 1, and we have to consider only 1 electron, because this 2 electron, in the last electron we should calculate that, so the effect will not due to that, so that this last electron will not consider, and minus 1, so that electron contribution is 0.35. if that is 1s orbital, then in that case also 0.30. then all the electron inside that cell, that means n minus 1 cell, then that is 0.85, and all electrons further inside that is only 1, then 0.35 for n cell, and for all n cell 1 contribution. In case of d and f orbitals, because of d or f orbital, d or f orbital, in that case first taking 0.35 for nth cell, but we will not consider 0.85. after that all that electron will go through 1. We should clearly understand by considering an example, but you have to remember all these to calculate the sigma or z effective value. So calculate the Z effective value for potassium 19. So first writing electron configuration, this is 1s2 2s2 2p6 3s2 3p6 4s1. So calculating on 4s1, because potassium ordinary Slater sigma equal to 0.35 on this minus, but we have to on this electron, but we should minus 1, so 1 minus 1, because we try to calculate a sigma value on that electron, so that electron will not affect the himself, so that it will exclude. So 0.35 into 1 minus 1, then all that inner, the next inner side is into 0.25, 6 to 8, so 8 into then 0.85. after that all that inner electrons into 1, 6 to 8 to 10, so 10 into 1 contribution, so that this is 0.30 into 0, 8 into 0.35 into 0, 8 into 0.6.80, 10 into 1, 10, so it comes out 16.80. this is sigma value, but we should calculate Z effective, so Z effective equal to Z minus sigma. Here gallium or potassium, this is 19, so 19 minus the sigma value 16.80, it comes to 2.20, which is the Z effective value for K19. After that calculate the Z value for iron. So this includes D and S subcell, here S subcell. So I have taken 2 examples to understand clearly. So first electron configuration of iron is 1s2 2s2 2p6 3s2 3p6 3d6 4s2. According to Slater's rule, this is on d electron, they ask d electron, so this 4s2 will not consider, because the electrons after that we want is have no contribution or 0 contribution. This 2 electron has 0 contribution, because they ask to calculate on d electron, but it is outside of that, so it will not affect to shielding effect, it will not shielded the electrons to attract, because it is outside of this electron. So after that this 6 minus 1, this is contribution is 0.35. according to rule you have to check in the last page, then 0.35, 6 minus 1 into 0.35, and all that they have told into 1, 18, 8, 8, 16 to 18 into 1, so it will come 19.75. this is again sigma value, so you calculate in Z effective, so Z minus sigma, Z is 26, this sigma is 19.75, it comes out 6.25. So after that we will see what are the consequences of effective nuclear charge or Z effective value, why we should study this, and what are the benefits to the periodic properties by observing the effective nuclear charge, what are the consequences or results of this value. So for us, due to this effective nuclear charge, 4s orbital is filled before 3d orbital, because 4s orbital has greater effective nuclear charge, so that it will fill fast. After that 3d orbital will fill because it has a more effective nuclear charge, so these 4s electrons are attracted by the nucleus, so that it will fill fast. After that 3d, then a cation is smaller in size, because due to formation of cation there is lesser number of protons but more number of electrons, so that this attraction is very high and this shrinks the cell size, so that cation size is small and simply anion size is large, in other words. And the successive ionization energy of an atom are in the following order. That means successive ionization energy increases because due to release of one electron each time, then there is also an attraction between the proton and the new electrons are very effectively, so that it will require more energy to remove an electron outside, so that successive ionization energy increases regularly. Then the next periodic property is size, atomic size or atomic radius. You don't think that these are short videos and it will not effective, because it is tricky channel. That means in lesser content I will try to finish all the chapter, and which should help you to solve all the problems that comes in your competitive exams like CSR, NET, GATE or IIT JAM exam, so that in few content or in less time I will give you the most required content, and the things that actually required to solve the problem, that only I will provide, and not the other things, that booky things that written. So that stay connected, I will tell all the things in the simple words which you will use in your future. So now let's see the atomic size or radius. The atomic radius of a chemical element is a measure of the size of its atom, usually the mean or typical distance from the center of the nucleus to the outermost isolated electron. So here is the definition of atomic radius. They told that atomic radius is one. It is the distance between the nucleus to the outermost electron. This distance is called atomic radius. As you go from left to right on a periodic table, as you go from left to right on a period, then atomic size or radius decreases. Why it decreases? Due to the fact that electrons added on the same cell, so increase in effective nuclear charge contract the cells. That means in a same period, when you go from left to right in a periodic table, then there is in the same cell then one more electrons are added. Due to addition of these electrons, then the attraction between the nucleus and the electrons increases, so that there is increase in attraction and Z effective so the cells are shrinkage or decreases their size or go towards the nucleus, so the size decreases. In the same case, as we go from top to bottom on a column in a periodic table, atomic size increases due to fact that new cells are added. Because when you go from top to bottom, then there is addition of more cells, new cells. In according along with the addition of cells, there is addition of electron, but in comparison that the distance between the nucleus and the new added cells are so much large, so that the cell size or atomic size or atomic radius is increases. So basically when you go to left to right in a periodic table, atomic size decreases, and when you go from top to bottom, then atomic size increases. In short form, you can remember by this symbol. That means this is 7. This is 7 or not? This is 7. But here arrow mark means when you go from right to left, then atomic radius increases. When you go from top to bottom, then atomic radius increases in a periodic table. So you remember only 7 for atomic radius. 7 means here. That means this side increases in period, same period. In group wise increases downward, in periodic wise increases leftward, that means decreases rightward. The same thing I described here, explained here, so you remember only 7. For the isoelectron species, this height of the species is follows. That means if in case of isoelectron species, that means species or elements which contain ions or elements which contain same number of electrons are called isoelectron species. Their size are or follows in this order. Anion in same electron, anions are greater size than the element, and this parent element greater than cation. One example, sodium plus, Mg2 plus, Al3 plus. The size is like this because due to removal of these are isoelectron species, but the size is in this order. This is due to the fact that when more and more number of electrons removed from outermost shell, then their Z effective increases. Due to the increase in Z effective, then their cell shrinkage and size decreases. This is another example. You can see ionic radii order. These two are ionic radii order, and you can see this. This is minus. That means electrons are added in cell, so that the electrons are added outermost cell, so that they are large inside. But in this case, electrons are removed, so that Z effective increases, so size is less. But in this case, Z effective decreases because more and more electrons added in the outermost cell, new cell, so that their size is in this order. So a periodic property completed, and I hope you like this video and the content I have given, you like it, and you have to read the content that I have written, and in the next video I'll do some questions on periodic properties. I think we will read and you will participate this question solving session, and thank you for watching.